Hi everybody, welcome back. Today we're going to be starting chapter 6, which is on forces. And I think many of us, when we think of force, or when the question is asked, what is force or forces or the force, we often think of Star Wars and Darth Vader and Yoda, where these characters can manipulate or influence objects at some distance. Well, of course, we as humans can't do that. We have to be in contact with objects to apply forces to them. But there are some forces that actually can act over distances, and I'll talk about those in just a second here. These forces right here. But what are forces measured in? Well, forces are vectors, which means they have a magnitude and a direction, and they're measured in a unit called a Newton. Now, Sir Isaac Newton is credited with coming up with a theory of gravity, which we know is an acceleration, but when gravity acts on an object that has mass, it applies a force to that, or it creates a force. So newtons are the units of force for our chapter. If you think about it, a newton really winds up coming down to, if you're standing on Earth, about a quarter of a pound. That's about how much a newton is. So you could go to McDonald's and ask them for a Newton burger instead of a quarter pounder, but they'll probably look at you funny. So anyway, Newton is our unit for force. So back to the main forces that exist in our universe. You can create forces with your arms, your limbs. You can create. That is, your arm can pick up a book, it can throw a baseball. You can create a force on any object. But ultimately, after a while, your arm gets tired. You can't hold a book forever. You can't throw a baseball infinite number of times. And so that ability for you to create forces goes away. There are, however, 4 forces that exist fundamentally in our universe: the gravitational force, the weak and strong nuclear forces, and the electromagnetic force that exist no matter what. And so our whole universe is actually defined and explained by these 4 forces. The first 2 I'm going to mention real quick, the strong and weak nuclear forces. These are simply forces that exist within atoms that hold subatomic particles together. We're not going to talk about it very much at all. In fact, after this, we're not going to talk about it at all. But they are 2 of the fundamental forces. That's all we'll say. I'm going to talk about the electromagnetic force briefly, real quick, before we get onto gravity. The electromagnetic force is actually a fairly strong force. Many of us have seen this happen, where you have a balloon at a birthday party and somebody rubs it on their sweater or something like that, and it builds up static electricity. Well, static electricity is one manifestation of electromagnetic force. And so this balloon can be actually stuck to the wall because of the electromagnetic force or static electricity that we've all seen happen. In comparison, the gravitational force is pretty weak. Gravitational force affects and acts between any 2 objects that have mass or that are made of matter. So if you think about it for a minute, just a few atoms here between the balloon and the wall, holding it to the wall, are able to overcome the whole gravitational force of Earth pulling this balloon down to the floor. So you might say the electromagnetic force is much stronger than gravity. And it is. In fact, the gravitational force is weaker than any of the other 3 forces. Even so, it has an infinite range. That is, anything that has mass creates gravity. So you create gravity, the Earth creates gravity, everything creates gravity, and it extends out in all directions infinitely. So you are pulling on some object across the universe right now with some tiny, tiny little bit of gravitational pull, and vice versa. So the gravitational force is the weakest, but it is infinite in range, and it exists between all objects that have mass. That's the one we're going to focus on the most this chapter. So of all those forces, we must now define what the net force is. Because of all these forces, You can have a gravitational force, you can have an electromagnetic force, you can have nuclear forces acting on an object. But really what we're going to care about in this chapter is what's called the net force. Now this isn't a kind of force, but it's simply net means what's left over. Like for example, when you get paid, your pay is $100, okay? But after taxes, of course we all pay taxes, that's minus $30, right? Oops, minus $30. So your net pay is $70. Net simply means what you have left over when everything else cancels out or goes away. Same is true of forces right here. Let's take a look at an object that we're applying a couple different forces to. All right, there's a force of 4 newtons acting on this box in this direction, and there's a force of 3 newtons acting on this box in this direction right here. Well, which way is it going to move? Well, you can probably say, all right, well, that makes sense. The box is really experiencing a force of 1 newton in that direction because really this force is counteracting that force and it's all going away, and the difference really is a force of 1 newton. We would call this the net force. And I'm gonna write it a couple different ways. Might say F sub net, like that. Would be 1 newton right here. Or we can write it like this. This is our Greek letter sigma right here. Oops, I forgot to write net force. Net force. This is a Greek letter sigma, which means sum of, not sumo, sum of all these forces. So if we sum up these forces right here, and I'm not really good at writing sigmas, so they look like backwards 3s really for me. That would be 4 newtons plus negative 3 newtons. All right, well down here we can see, all right, sum of the forces equals 1 newton. So this is going to be important for us to add up all the forces in whatever direction they're acting and find out what the net force is, the sum of these forces.